The motor which powers the motorcycle to run is generally an internal combustion engine. When we ride the bike, several explosion is taking place inside the cylinder and gears are rotating to transfer power. Countless explosions taking place inside the cylinder, which, along with the frictional forces of the various moving parts inside, generate a tremendous amount of heat. To reduce friction in the cylinder and other moving parts, we use engine oil. This engine oil can reduce friction only up to a certain temperature and reduces performances. As we try to run the engine at a higher speed, a higher amount of heat is generated due to friction and combustion, which results in heating of the engine. For a smooth running of the engine, as well as to maintain optimum performance, the engine needs to be cooled down. Depending on the application currently, the cooling is done using three technology: air-cooled, oil-cooled, liquid-cooled. This cooling force will keep the temperature in check and allows the internals of the engine to perform at an optimum level, as overheating can cause the motor to seize and self-destruct. Air-cooled. As the name implies, this type of engine uses air as the cooling agent. This is the most basic method among the three, where the natural air is used as a cooling agent. Air-cooled engines are easier to manufacture, are cheaper and pretty easy to maintain. Fins are the extended metal surface as you see on the image. The engine cylinder is surrounded by fins on the outside that create channels for passing air to take away the heat dissipated by the happenings inside. The fins also increase the surface area of the casing, allowing the heat to dissipate quickly. This method is usually adopted for small capacity engines that generate a lesser power and designed to run at a slower speed. Some large capacity bikes use air cooling, but they are not designed to ride at faster RPM. Air cooling is not the most effective way to cool the engine. This method of cooling is generally used in a low-budget commuter bike and higher capacity, which is designed to run at lower RPM and is a cost-cutting. Oil cooling. In addition to the air cooling, this method also makes use of an oil cooler, which cools down the temperature of the engine oil. We know that engine oil is circulated within the engine. When the engine becomes hot, the engine oil will also become hot and starts losing its property and fails to reduce friction. To avoid this, and to make sure that the engine oil maintains the optimal operating temperature, it is circulated between oil cooler. The hot oil is pumped into a radiator, which transfers the heat to the atmosphere and gets cooled. The cooled engine oil is sent back again into the engine and retains its viscosity and minimizes friction. However, since atmospheric passing air is still the basic element used, where cooling improves only when speed rises. Oil cooling is not as efficient as liquid cooling and cannot be installed on high-performance engines that produce huge amounts of heat during all operating conditions. In short, this is more efficient than simple air cooling. Liquid-cooled. Liquid-cooled engines can maintain high speeds for a long time, and the performance is also maintained. They also have a longer life as compared to an air-cooled engine. Just like the oil-cooled motor, a special liquid coolant is circulated to hot cylinder and get heated up. The hot coolant is forced into a radiator and transfer the heat to the surrounding, and finally, the coolant gets into the engine to take away the heat. Additional fans are used to cool the radiator when moving at a slower speed. This engine cooling is costlier and complex to make, relatively costlier to maintain as well. Whichever cooling system the engine of your two-wheeler employs, make sure you don't run an air-cooled engine near its red line for really long durations. Top up oil levels regularly if the motor is oil-cooled, and keep a check on the coolant and its delivery systems if your bike has been fitted with a liquid cooling setup.